So in this problem, we are given the equation of a parabola. So using this equation, we need to find out the coordinates of the vertex and the focus, equation of its axis and directrix, as well as the length of the latus rectum. Let us begin. So what we'll do, we'll start with the given equation of the parabola. So here we have y squared minus 8y minus x plus 19 equals to 0. So let's do one thing, keep the first two terms and then transpose the third and the fourth term to the right hand side to get x minus 19. We'll try to convert y squared minus 8y into a perfect square. For that, what we can do, we can take the help of the second term, rewrite it as 2 times y times 4. So here 4, the number 4 is going to tell us that we need to add square of that particular number, and that's an extra number that we are adding, so we need to subtract 4 squared from it as well. That will be equals to x minus 19. So that gives us y squared minus 2 times y times 4 plus 4 squared equals to x minus 19. So we are going to transpose negative 4 squared to the right hand side to get positive 16. Now the first three terms on the right hand side, that's nothing but y minus 4 whole squared. This will be equals to x minus 3. So let's label this as equation number 1. Now what we'll do, we're going to make a substitution here. So let the value of y minus 4, let this be equals to y in uppercase, and x minus 3, let this be equals to x in uppercase, such that our equation number 1 now transforms to y squared equals to x. Now what to do? This particular equation is comparable to the form y squared equals to 4ax. So this is the equation of a parabola in its standard form, and let's try to understand it graphically. So here we have the coordinate axis, we have the x-axis and the y-axis. So here x and y-axis are represented by the letter x and y in uppercase. Now we know that y squared equals to 4ax. This is a parabola whose vertex is going to be at the origin 0, 0, and it is going to be a right facing parabola. And the focus is going to be along the axis of symmetry line. Here x-axis is going to be the axis of symmetry line of the parabola, and the coordinates of the focus is going to be a, 0. Next, we have, this is the axis of symmetry line, which is the x-axis, and we know the equation of the x-axis is given by y equals to 0. Next, we also have to define the directrix of the parabola. So what we'll do, we'll consider another point B. Now B is chosen in a very specific way, such that its distance from the vertex of the parabola, let's say this is the distance t, this distance must be exactly equals to the distance of the focus from that same vertex. So that's how we can define the point B. Now B is chosen in this way, so that if we pass a line through that point B, we're going to get a line which is going to be perpendicular to the axis of symmetry line, and that's going to be the directrix of the parabola. Now we can also define the coordinates of point B. The coordinates of point B is going to be negative a, 0, since it is equidistant from the vertex. Now that we have the coordinates of point B, we can also define the equation of the directrix. So the equation of the directrix is going to be the line which is parallel to the y-axis and passing through the point x equals to negative a. So that means its equation is going to be given by x equals to negative a. We have the directrix, and we can also find out the length of the latus rectum. Or by definition, latus rectum is defined as the line which is going to be passing through the focus, and it's going to be perpendicular to the axis of symmetry. And also when we extend this line, its endpoints are going to be lying on the parabola. So this particular distance, this distance is nothing but the absolute value of 4 times a. So here we can find out the length of the latus rectum. So using this information and our equation that we obtained, y squared equals to x, let's try to find out all of these values. Okay, so we'll start with the vertex. So our vertex is given by, so we have x, y. So that corresponds to 0, 0. So we have to be careful here. We're going to consider, we are considering here the new coordinate axis. That means x and y represented in uppercase. Now We'll come to the lowercase in a moment, but first let's note down whatever we obtained. Then we have the coordinates of the focus. So focus came out to be as x comma y, so that corresponds to a comma 0. Now we have to find out the value of a. So here, when we compare y squared equals to x with the standard equation, then this is going to give us the value of 4a equals to 1, which means that the value of a equals 1/4. So that means our focus comes out to be 1/4 comma 0. Fine. Then we have the equation of x's. The equation of x's we obtain it as y equals to 0. Then we have the equation of the directrix. The equation of the directrix is x equals to negative a, or simply put, we have x equals to negative 1/4. And then finally, we need the length of the lattice rectum. So the length of the lattice rectum, that will be equals to 4 times the absolute value of a. So here a corresponds to 1/4. So where 4 multiplied to 1/4, so that gives us 1. But we have to be very careful here. These values are obtained with respect to the new coordinate axis. However, we will have to revert back to the original coordinate system, which where x and y are taken in lowercase letter. So that's fine. All you have to do is replace the value of x. So here we consider x to be x minus 3 and y to be y minus 4. So if we replace the value of x with x minus 3 and the value of y with y minus 4, so that's the vertex. Now we can rewrite this as x comma y. This will be simply equals to 3 comma 4. Then we come to the focus. So focus will be x minus 3 comma y minus 4. So we obtain the focus value as 1/4 comma 0. So we're going to get 3 added to 1/4. So that will be 13/4. Then we have 4 added to 0. So that's going to be 4. And then coming to the equation of x's. So here we had originally obtained y equals to 0. But transformed will be y minus 4 equals to 0, which means that y will equals to 4 would be the equation of the x's. Then coming to the equation of the directrix, we obtain x equals to negative 1/4, but we have to replace the value of x with x minus 3 equals to negative 1/4. So solving for x, we get x equals to 3 minus 1/4. So we're going to get 11/4. That's going to be the equation of the directrix. And length of the lattice rectum, that's going to stay as 1. So length of lattice rectum, that's going to be equals to 1. So these are the coordinates of the vertex. We have the coordinates of the focus. We have the equation of the axis, y equals to 4, equation of the directrix, that's 11/4, and the length of the lattice rectum given by 1.